Right, welcome back to area between the curve. So now we're looking at these two. We have x, so f of y, right? So the function with respect to y this time, x equals the cube root of y, and x equals 2y squared. All right, so first we need to graph the functions and see the defined area. But notice now that we're solved in terms of x. When we integrate, we're going to have y's. So now it's going to be a dy. And there we go. All right, so there are the two graphs. All right, so we have in blue is the cube root of y. In red is 2y squared. Notice they intersect twice. And so this time, we're not looking at upper and lower. So yes, if we were looking at the graph from upper to lower, we see red then blue, but no, because we're solved for y's, now it's right to left, right? So blue to red. All right, so first of all, we need to find our points of intersection. You set your two functions equal to one. Actually, not first. After we've graphed, second, we need to find our points of intersection. And so we set the two curves equal to one another. Cube root of y equals 2y squared. All right, so you cube both sides. You have y equals 8y to the 6. All right, and then you're going to get everything on one side, so you can factor. You can pull out a y. And so y equals 0 is 1, and then you're going to need a calculator because the fifth root of 1/8, not a pretty number. So you'll use a calculator to find what that point is. Let's take a look at this one solved out. All right, so now we need to, we found the intersection. Notice that h is the difference between the two x coordinates. You have horizontal stripes. Right, so when we're integrating with respect to y values are the boundaries. Right, so we're looking at the y values, not the x values. But that's okay. When we solved it, we were solving in terms of y because it was x equal. We were solving for y's. Right, we had y equals 0, and we had y equals the fifth root of 1/8. Right, so we had it set up so that we would find y values. So the fifth root of 1/8 was 0.66129032. All right, so now it's going to be so it goes from the high minus, so the larger values minus the smaller values. So it's going to go from right to left because the right values are larger. All right, so it's going to go blue minus red. It's to be right minus left, and your boundaries are going to be y values because you've got y. It's dy, not dx. All right, so we're going to integrate y to the 1/3. I rewrote that. dy minus 2y squared dy. And those are going to be evaluated from 0 to 0.66129032. Straight integration here. That's why I didn't bother to erase it and not have to write the numbers again. And I didn't even find the total value there. Did I? No, because I didn't plug it into the calculator. But that's all that's left at this point is to plug it into the calculator and fill in the blanks. All right. So maybe I'll go run and grab a calculator. I don't know if it's all that important, as long as you know the steps. All right. So we'll integrate. That would be 3/4, right? Because we're going to add 3/3. And we'll divide by the same thing. Divide by 4/3. You're going to have 3/4. So 3/4 y to the 4/3 minus, and then 2/3 y cubed, right? You add 1 and divide by the same thing. And I already had a coefficient of 2 on that. And now all you do is substitute and evaluate. So if you really want to know what the answer was, let's see. So 0.66129032. Raise that to the 4/3 power. It takes more time to plug this into the calculator than it did anything else. And then times 3/4. So we've got that in the calculator. And then, so I've got 0.432099885 for this one. 0.432099885. minus, oh, and so the minus 0. So would be, if I plug in a 0 into either one of these, it would be minus 0. Right, so if I plug in the 0 into the first one, it's a 0. If I plug in the 0 into the second one, it's a 0. So I end up just with the ones that got the decimal plugged into it. So when we have the same point, 66129032 to the third power times 2/3 gives us, so oops, stick with the green pen, minus 0.1927903259. You can't even squeeze that in there. And so finally, we'll just subtract those two. So 0.432, that was a 0. 099, good thing it's all on the calculator, 885 minus my previous answer, so I'm not typing that in again. So here's your area, equals 0.23930955591. If you want as many decimal points as I could possibly find in the calculator. There you go. So now it was just a calculator problem. There's the area under the curve. All right, easy problem, not pretty numbers, but easy problem. So when we integrate with respect to y, just remember your y values are the boundaries, and this is going to be a dy. All right, let's look at another one. So these couple, the integration was so simple I didn't really bother to erase it. Notice, notice this distance uses coordinates from right function minus coordinates from left function. All right, so always has to be right minus left. Otherwise, you're going to end up with a negative area, and it's not going to be a negative. All right, so here we go. Here are our two functions. We could solve the line for either x or y. It could go either way. But it would be much easier if we integrate with respect to y because of the y squared minus 9. All right, we're not going to be able to solve for y because we're going to have a plus or minus, and that's just going to be a mess. All right, so if we solve for x, it's certainly easy enough to solve the line for x. X is the way to go here. You don't want, you can't, there's nothing you can do with the y squared. So we're going to just have x equals y, negative y. So this one here would be, the red curve is just going to be x equals negative y plus 3. There we go. All right, so now we can integrate with respect to y, and it's going to be the right minus left. So it's going to be red minus blue. And, oh, you know, I think I erased that, the setup. Let me do the setup over here. And then I have the answer on the next page. That's the easy part. All right, so not that this was all that difficult. So it's going to go, the red curve is the one that's to the right. So right, and it's a dy. And now these values are y values. And then minus, and the blue is the left. And it's the same values. All right, so we need to find our point of intersection. I even shade in the area. I like my area shaded in whenever possible. Look how pretty that is. Look how nice the coloring is. Staying in the lines and everything. All right, so there's our area that we're finding. All right, so go back to green. So it's going to be, we're just going to set, we've got it isolated, negative y plus 3 equal to y squared minus 9. Move everything to the right side. So 0 equals y squared. This would be plus y. And so we have minus 9 minus the 3 is going to be minus 12. This factors to y plus 4, y minus 3, a nice easy factor in there. right? So y is equal to -4, and y is equal to 3. I don't really care what the x values were. So this point here, that's 3. And this point here is 4. Actually, if you want to know the exact value, you know what? I'll write it in as a point. So as a point, if I plugged in the 3, that would be 6. Excuse me, 0. Yeah, my line is a little crooked. That's a little misleading. There we go. Yeah, that looks better, actually. If it's 0, it should be on the x-axis. I mean the y-axis. All right, so here, that point of intersection is 0, 3. And the other one is 7. So this is 7, -4. Because that would still give us 3. All right, and the values we want are not the x, but the y values. All right, let's hope that's what's on the next page, that it's integrated from -4 to 3. I can only hope. Oh, it looks like I solved over. No, I didn't solve over here. I just did the integration. And I just did the evaluation. So let me actually write down what we're integrating, and then we have the evaluation on the next page. I forgot what was on there. Oops, not A and B. I want the actual values. So that would be -4 and 3, and it's the red that goes first. So that is -y minus 3, or -y plus 3 dy. Contact lens is all fuzzy, so I have to like wink to look at things. And then minus y squared minus 9 dy. And this is a straight integration, no substitution here. So this would be -y squared divided by 2 plus 3y minus y cubed divided by 3. And then let's just distribute the negative. Minus a negative is going to make that a positive 9y. And I don't know that I combine the like terms, and that's from -4 to 3, but I really should, instead of having to plug in twice. So this would be -y squared divided by 3. Actually, you know what? Let's write them. You know, I may as well write them in order. I don't know whether I did that or not, but I've already distributed the negative. -y cubed divided by 3 minus y squared divided by 3. Oops, wait. Oops, I'm sorry. Why is that a 3? That's supposed to be a 2. Was I looking at the 3 right next to it? Well, I'm glad I rewrote it. Caught my little error there. I don't know why I wrote a 3. Right? And then plus a 12y. You don't have to change the order, but I already distributed the negative, so it doesn't really make any difference, their order. So long as I plug in 3 for everybody, and then I plug in -4 for everybody. So I don't know how I wrote it on the next page. I think I have it literally just like this, and I don't even think I combined the like terms. Did I? Yeah, I did. I did. And this time I went the opposite way. I went from the least degree to the greatest. So you're going to plug in the 3 first, and then you're going to plug in the -4 and simplify. I don't think I need to go step by step through the multiplication and addition and subtraction. But the final answer was 343.6. If you have any questions on this evaluation, on this page here, just let me know. But I think you're fine to just look at that answer. I have an already made podcast so I'm going to where this one ends, where my other podcast begins. All right, so here we're finding, I think this might be the last one on this tape. When finding the area between x equals -y squared plus 5y, all right, we need to find our lower, and the y-axis. All right, so this is with the y-axis, that is the equation x equals 0. So notice that our equation x is isolated, and our function now is in terms of y. So this is going to be horizontal stripes. We're integrating with respect to y. Okay, we're going that other direction. All right, and so our two equations are x equals 0 and x equals negative y squared plus 5y. So to find our, it's already written in terms of, when we go to solve, we're solving for y's. So we don't have to worry about, we solve for x's, what's the y value? What we get is y values, right? Because our equations are written in terms of y's. So we just set those equal to one another, and it's an easy factor. So our 2 boundaries, our lower boundary is 0, and our upper boundary is 5. Now it's an easy integration, because now I don't even have two functions really, because my other function is 0. I don't really need to have minus 0 because it's x equals 0. So technically, my area is going to be right minus left, but my left is 0. Right? So I don't really need to write in the 0. Right? So I have, we're integrating negative y squared plus 5y from 0 to 5. That becomes negative y cubed divided by 3 plus 5y squared divided by 2. Easy integrations here. Not even a substitution. Not a trig function. This has been easy. From 0 to 5. All right, so now we just evaluate. So we're going to evaluate for 5, and then we'll evaluate for 0 and subtract. Of course, when we plug in 0 to either one of those, we get 0. So then it's just going to be what we get for 5. But I would still make sure, I always write those down. You want to make sure that you're not going to end up, sometimes when you plug in 0, you still end up with something, if there's a constant there. So we have negative 5 cubed divided by 3, plus 5 times 5 squared divided by 2, minus 0, and simple little evaluating here, getting same denominator. 125, 6 is the area under the curve. And that's the end of this problem, right? So like I said, if you have questions, and I'll be there to help you in class on your class problem, on your homework problems. If you have questions, though, let me know. So this is my last page. General strategy for area between the curves. First thing you're going to do is sketch your curves. You're going to decide on vertical or horizontal strips. Pick whichever is easiest to write formulas for the length of the strip, and or whichever will let you integrate the fewest times. I mean, Betty functions, I could do it either way, x or y, but one of them will be easier. And I will not have to break it up into little pieces, right? We'll see how we break it up in little pieces in a later podcast. You want easiest, right? Whatever is the easiest. I can't have, like, for instance, I can't solve y squared. I can't isolate y. Okay, it's not possible, right? So x was the way to go on that last problem. All right, so we want to write, or the problem before that. And then we're going to write an expression for the area of the strip. If the width is dx, the length must be in terms of x. So it's top minus, the curves are top minus bottom, and the points of integration are going to be x values. Actually, I had that a little bit below. So it's going to be top minus bottom for dx. It's right minus left for dy, right? So if you're integrating in terms of x, it's top minus bottom. If you're integrating in terms of y, it's right minus left. Always, always, always. You'll find the limits of integration. If using dx, the limits are x values. If using dy, the limits are y values. Integrate to find your area, and then plug in the values and simplify. I believe this is in your notes. If not, please write this down, all right? Because these are your steps, and they are consistently your steps. We'll see a few things where we have to do a little bit more, but once we've done that little bit more, these are our steps, all right? So that's the end of this podcast. I'll pick up with a podcast I've already made, and we'll see some more areas between the curves. Thanks for watching. Bye.